So we're going to have a look at this linear motion question 1 from 1988. So it's a question about vertical motion. A particle has fallen from rest at a point 0 and passed 3 successive points, so A, B and C. We're told that the distances from A to B and B to C are equal, so I'm just going to call that distance x in both cases, and that the time taken to go from A to B was 3 seconds and the time taken to go from B to C was 2 seconds. And we have to calculate this distance x, the value from A to B. So a couple of things to note before we start the question. So first of all, the object did start from rest, but it wasn't at rest at point A. And so what we're going to do is we're just going to assign an initial velocity, and we're going to call that initial velocity at point A u. We also note that the object is obviously speeding up due to gravity, so acceleration is 9.8 meters per second squared. And this is demonstrated in the question as the distances from A to B and B to C are equal, but the time taken to go from B to C was 2 seconds, which was quicker than the time taken to go from A to B. So obviously the particle or the object is picking up speed or velocity as it is accelerating under gravity. Now the key to a question like this is that we need to use this common initial velocity of u when setting up equations. So we're going to make an equation for the distance x from A to B, which took 3 seconds and had an initial velocity of u and obviously an acceleration of 9.8. But we're not going to make a second equation then from B to C. If we make an equation from B to C, the velocity at point B has changed and it's no longer u, and we'd have to create another variable, an extra variable in the question to try and proceed and make an equation from B to C. So what we do instead is we want to start back at point A using that common initial velocity of u and make an equation from A to C. So remember, at this point A we have an initial velocity of u, and we can keep that same velocity for the equation A to B as we can for A to C. So A to C took 5 seconds, obviously 3 plus 2, and was an overall distance of 2 times x. And so they're the two equations we're going to make. One for A to B and another one from A to C, so that we can use again that common initial velocity u. So let's have a look at the equation from A to C. We're going to use the distance formula. S is equal to ut plus a half at squared. U is u, acceleration is 9.8. It took 3 seconds to travel that distance of x. And so let's sub these numbers into the formula to give us that x is equal to u times 3 plus a half on 9.8 by 3 squared. And tidying this up, we get x is equal to 3u plus 44.1. And I'm just going to label this equation 1 for our system of simultaneous equations. The second distance is the distance, remember, from A to C. And the distance from A to C, again, had an initial velocity of u, an acceleration of 9.8. This time it took 5 seconds and the overall distance was 2x. So we're going to sub them into the same distance formula, s equals ut plus a half at squared, to give us that 2x is equal to u times 5 plus a half on 9.8 by 5 squared. And tidying this equation up, we get 2x is equal to 5u plus 122.5. And this is going to become equation 2 for our system of linear equations. So we have two variables, and so what we're going to do is do a simultaneous equation to try and eliminate one of the variables. So equation 2 is going to be 2x equals 5u plus 122.5. But to eliminate the x's, I'm going to multiply equation 1 by minus 2. So that equation then becomes minus 2x equals minus 6u minus 88.2. I'm going to draw a line underneath. I'm going to cancel the x's. 5u minus 6u is minus u, and 122.5 minus 88.2 is plus 34.3. I'm going to add a u to both sides to give me that u is equal to 34.3 meters per second. So this initial velocity at point A was 34.3 meters per second. I'm going to use this value with either equation 1 or 2 to solve for x, which is the value that we're looking for in the question, the distance from A to B. So I'm going to sub this back into equation 1. So I get x is equal to 3 times 34.3 plus 44.1. And so x is equal to 147 meters. And so the distance from A to B in this question is 147 meters. So again, key to a question like this is when we're setting up equations, we need to go back to this point A. We need to set up an equation from A to B so that we can use this value of u. but also then we need to go from A to C so that we can use the same variable u. Had we tried to set up an equation from B to C, that u value has changed in going from A to B. The initial velocity is no longer whatever u is, it has changed to something else, which means either introducing a new variable or trying to do another equation to find out what that velocity is in terms of u at B. And so it gets a little more complicated if we try and do it that way.